Hi there, this is Jacob Nash Precalculus Lessons, and this is Unit 0, Lesson 1. So, that would mean this is the first lesson of these videos, and this is the fourth class that there has been videos on by Jacob Nash. There's been geometry ones, there's been engineering ones, and there's been also algebra ones, and now precalculus ones. Already said that I was going to do that anyways. So, it is August 2021 when this video was made, and the first Jacob Nash video was made in January 2020, so even though I have done that many classes, still not that many years, only 1.5, I guess, more than 1.5, but whatever. So, before we get started, these will just be videos on precalculus lessons, and as I've said with all the other courses that I've done, this may not go over everything that you need to know for your class, and I'm not a certified teacher, so occasionally I can make mistakes, and so please make sure that you don't just rely on these videos if that's what you're trying to do. I know sometimes things like this can be hard for some people, but you can use this as a guide, but it shouldn't be the only thing that you use. So, this is the first unit, that is Unit 0, and these are things that you should know already, or you should have learned at least in Algebra 2 before going into Precalculus. But, you forget things sometimes. So, remember your exponent rules? No? Fine, learn it again. But you might remember these. It was only like few months ago when I made a video about this for the algebra one. So I'm not going to go into much detail since you already should know this, but if you want more detail, go on JNAL. So, the first rule, and these are not words, so I'll say them in words, but they're in symbols. So, you see a to the b power times a to the c power equals a to the b plus c. So when you have two variables or numbers that are being multiplied by each other, you add the exponents. So if you have, and you can only do that when it's the same base. So if you had x times y, that's not, you can't do anything. That's all you did. And then the exponent rule doesn't work even for numbers. So let's say you had 2 times, let's say like 8. Well, you can't add the exponents, because then what you would do is you would think 16 to the second. No. The answer is 16, and it's not 16 to the second. So only if the bases are the same, this works. That's why it's both A's. So that's what that means, and we'll see an example of that. A to the b power divided by a to the c power, you subtract the exponents. Remember that? You subtract them. And then a to the 0 power equals 1. So anything that has an exponent of 0 will always be 1. So that's what it is. And if it has an exponent of 1, then it will always be what it already was. Because if something doesn't have an exponent, it really does, and it's just 1. So a to the b power to the c power. So that means that you're doing a to the b power and then to the c power also. You multiply the exponents. Also, if you have two different variables in parentheses to a certain power, like a, b to the c power, the c doesn't just go to one of them, it goes to both of them. That might seem more obvious when it's variables, but when there's numbers, you need to remember that too. But pretty much you would want to simplify what's in there first anyways. But then this is kind of the same thing. A divided by b to the c power, the c goes on the a and the b still. Rule number 7, when you want to make a radical into a exponent, that's what you can do. So let's say you have something like, this is how this one can be useful. Let's say you have 49 to the second power, and then the square root of that. You just might be like, oh, that's dumb. Well, then, if you didn't know what that was, your A is 49, your B is 2, and then the index right here is C. There's nothing there. That always means 2. So 49 to the 2 over 2 power. 2 over 2 is 1, and I already said anything to the first power is what it is. So it just is 49. But you would know that because these cancel out. Anytime you have a square and a square root, that cancel out. But if there was like a 3 there, then it wouldn't. So that's how that can be useful. So practice, well, this isn't necessarily practice, but it's just examples of how these rules apply. So there's 7 different things, and that's all the 7 rules. So the first one we said you need to add exponents when you're multiplying things. So don't say that equals x to the 6th. No, it equals x to the 5th because we add the exponents. 2 plus 3. Here, since we're dividing, we do x divided by x to the 5th divided by x to the 3rd. 5 minus 3 equals 2. So there you go. X to the 0 equals 1. So you subtracted them there, and then anything to the 0 equals 1. We already know that. X to the 2nd to the 5th, we multiply those exponents. 2 times 5 equals 10. So if I'm going too fast for you, please see Jake Nash algebra lessons for more. But this should just be a review. I don't know why you would be in Precalculus if you didn't learn this. It could have been just a few months ago when you learned this, or it could have even been a year and a half ago if the way that your classes went. You never know. So here you want to distribute this because I said that goes on both. So x to the, you multiply it, so 12th, and then y to the 18th. There you go. Now here, same thing. Distribute x to the 15th divided by x to the 10th. And you can still simplify this because, remember, now we can, since there's the same base, you can subtract the exponent, so x to the 5th, 15 minus 10. Here, we can change it to exponent form. We don't necessarily have to, but we can just say x to the something over something. Here, since there's no number, there's really a 2, and you always have this number and here with the index on the denominator. So x to the 7/2 is what that is in exponential form. Now the problem, we have a problem. Let's see, that we'll have to use lots of different rules for this. So since this is in parentheses, we need to put this exponent here. But before we do that, it would be better if this is in exponential form. So that would be x to the 2/3. So if you see the two numbers, they change order and then our numerator and denominator. That's always what happens. So we have that, and then we'll multiply that by 3, because that's what we do when we distribute. And then 3 to the 3rd, we'll leave that like that for now. Then down here we can have 9. Let's change this to exponential form. X to the 5/4. Or wrong way, sorry. 4/5, actually. Now we know that 3 to the 3rd, or cubed, is 27. And then multiply that. 2 times 3 is 6. 3 times 1 is 3. 6 divided by 3 is 2. So that's what that equals. So 6 over 3. That's how you multiply fractions. Hopefully you know how to do that. And in Precalculus, you don't always use the calculator as much, so you need to remember some of these things. Then 9 x to the 4/5. Now, to keep simplifying, the 27 over 9 goes to, that becomes 3. Then 2 minus 4/5. So, like I said, you want to know your fraction rule. So instead of let's not just type this in the calculator, let's actually remember what we do. So 2 over 1 times or not times, what am I thinking? Minus 4 divided by 5. Remember, anything, the 2 goes over 1 because that if it's just 2, it's over 1 always. To subtract, when multiplying and dividing are actually easier because you don't have to make the denominators the same, but you do if you add or subtract. Let's just make them both 5. That's simpler. How do we do that? Well, for this one, you just multiply that by 5 to make it be 5. But since you do that, you also have to do it to the numerator. So that would be 10 fifths minus 4 fifths. 10 minus 4 is 6. And then we still have that 5. That's all it does. And so that means we have x to the 6 fifths. But we can also change that to radicand form. And then we do x to the 5th. And then 6 is the index. Or wrong way again. Messed up again. That would be 6 here, 5 here. And as we know, we could pretty much do this. Well, we don't really need to do that because you don't always have to simplify more, but since the exponent is larger in here, you could simplify that further. That's what you would do in Algebra 2, but you don't always have to do that. And for time's sake, we'll not do that because that's not what this video is about. Anyways, answers, we got it right. Good. Now, last thing that I forgot to say as a rule is negative exponents. A common thing that people think is if you have a negative exponent, like, let's say, 3 to the negative second, you might think, oh, that may, well, since 3 to the second is 9, then 3 to the negative second is negative 9. No, that's bad, very bad. It's okay if you think that. Well, you should not think that because you learned it, but it's okay if you think that right now, but just remember that doesn't make it like that. It makes it a fraction. It makes it a fraction, not a negative number. If that was negative, well, actually, if that was odd and that was negative, then it would be negative. But for this sake, we'll just what it means. 3 to the negative half. Common rule is, if I want to put this into the symbols, if you have a to the negative b, then you can do 1 over a to the b instead. That's what you can always do. So in this situation, 3 would be a, negative 2 would be b, but it becomes positive. So 2, and then 1 over 1, so that would mean 1/9. So that makes it 1/9, not negative 9. That's a common rule to know. So one more thing to look at is that if we had x to the 15th over x to the 22nd, what would we do? We would subtract the exponents. We know that. And that would make us get negative 7. So our answer is x to the negative 7th. But we should change that, well, in most cases, you would want to change that to 1 over x to the 7th, because sometimes they don't want you to have negative exponents. So that would be what that is. And also, when you have a problem like this, I'm just making up things here. What you can do is you could say, well, to simplify, you subtract the exponents, so negative 9 minus negative 7. That can get confusing because that's really this, because two negatives make a positive. But an easier thing to do is you can just switch what sides things are on if they're negative. So since this is a negative 9, we know it's going to be on the denominator. And when you have a negative number in the negative exponent in the denominator, it goes to the numerator. So we can make this y to the second also go down here. This x to the 7th go up. And then this y to the 1st, or just y, that's what you can say too, go on the numerator. Now we can solve. 7 minus 9 for x would be x to the negative 2nd. 1 minus 2 for the y's would be -1, and then we could further change that to this. So there you go. That is review of exponent rules. So hopefully this helped. Feel free to comment if you have a question, but as I always say, I might not be able to answer because this isn't like a job and I don't get paid on YouTube. So that will be it for this video. Thanks for watching, and I'll see you on the next one.